Next, these are the 7.7 homework problems. So the first set of problems are asking you to rewrite these in the standard form. Well, 4 is the a value, so there is no imaginary, so it's going to be 4 plus 0i. For number 12, there is no a value, so it's 0, and then plus 2i. 13, square root of 25 is 5, and there is no imaginary part. And the square root of negative 100 is 10i, so it would be 0 plus 10i. Number 19, you're going to want to simplify this. Root 12 is 2 times 2 times 3. So you're going to pull the 2 out after we're going to leave the 8 alone. So this is going to be 2 root 3i. Number 20, square root of negative 9 is 3i. Square root of negative 81 is 9i. And that gives you 12i. 98. 98, if you broke that up, you get 2 times 49 and 7, 7. So you get 3 plus 7 root 2 with an I. And 22, square root of negative 9 is 3i. 3i plus 7i is 10i. And now we're adding and subtracting. This is a complex number, and this is a complex number. We're going to add like terms. 3 and 1 is 4. 7i plus negative 3i is 4i. We are adding these two complex numbers. Negative 4 and 2 gives you negative 2. 5i minus 4i is 1i. We have 1 plus, this is going to be I, plus negative 18 minus, this is 13i. And there was no reason for me to put that negative 18 like that. So now we're going to add these two. These are like terms. You get negative 17 minus 12i. Number 32, I would rewrite this as root 3i. Now sometimes, notice how they put that I in front. You can do that, or it can go in the back. It really should go in the back because it's the b value I. So this should be written root 3i. So 16 and 17 is 33. And these two are going to give you negative 2 root 3i. The square root of 4 is 2. Okay, this is 45, negative 45. So we have 45 is 9 times 5, which is 3 times 3. So we have 3 root 5i plus, this is the square, negative 1 times the square root of 25. So this is negative 5, and then plus root 5i. So these two are alike. They add to be negative 3. And actually, these two are alike, so you're going to add the coefficients. These are your b values. So that's going to give you negative 2 root 5i. In 38, number 38, square root of 20 is 2 root 5 minus, you're going to take the 2 out. You have a root 3, but you have an I. And then plus 2 root 5 plus 75 is 3 times 25 and 5 times 5. So this is 5 root 3I. So these two are alike. 2 root 5 plus 2 root 5 is 4 root 5. And these two are alike. You're going to add the 5 minus 2, which is 3 root 3I. $39, you are just going to multiply. 3 times 2 is 6, and then minus 12I. Number 40, negative 2 times negative 3 is 6, and then minus 2I. 41, 4I plus 9I squared, and I squared is negative 1, so this whole thing is actually negative 9. $45, you're going to turn negative root 16 to 4I. And you're going to distribute. 4I times root 3 is 4 root 3I. And then 4I times 7 is 28I squared, which this equals negative 28. Because I squared is negative 1. Negative 1 times 28 is negative 28. And put it in front. Okay, this one you're going to want to convert this. Square root of 24. So 24 is 8 times 3. And 8 is 222. So we're going to take a 2 out. So you have negative 2 root 6I. Now you have a root 6 here minus, and this is going to be square root of 3I. Now when we distribute, you're going to multiply this times this. So what you have here is you have 2 6's underneath the radical, and it's a square root. So you're going to pull that 6 out. So it's really square root of 36. So it's 6 times negative 2, which is negative 12I. And then a negative times a negative is a positive. And then this is going to give you, right here, you have, so the negatives cancel. So you have 2 root, this is 18I squared. Well, the I squared is going to be negative 1, so that's going to make that a negative 2. And you can take a 3 out of here. So the 3 and the 2 give you a 6. Multiply to give you a 6. So if you think of 18 as 9 times 2 and 3 times 3, you're taking that 3 that's in here, multiplying it by the 2. But because this is a negative 1, this ends up being a negative 6. And then don't forget 2. That 2 stays underneath here. The only thing different I would do about this is I would put this piece in front. So this answer should read negative 6 root 2 minus 12I, because you want it in standard form. 27, pull out the 3. You have a 3 remaining, but you have an I. This is root 3, and then root 3I. So when you multiply these two, that 3 is going to come out. So 3 times the 3 is 9. 9I, and then minus these 3's, that 3 comes out. So you have 3 times 3, which is root 9, which is 3. 3 times 3 is 9, so it's 9I squared. And this is actually equal to plus 9. So your answer here would be 9 plus 9I, because that equals 9. FOIL, 10 times 10 is 100. 10 times 3i is 30i. Oh, and we're minusing 30i, so those are gonna cancel. And then minus 9i squared. Those cancel, this is gonna be plus 9, so it's 109. 52, negative 4 times 2 is negative 8. And this is plus 20i, plus 6i, and then minus 15i squared. So this whole thing is actually equal to 15. This piece equals 15. 15 minus 8 is 7, and then plus 26i. And we have, we're going to rewrite this as 7 plus root 2i, and 5 minus 2 root 2i. So when we FOIL, 7 times 5 is 35, minus 14 root 2i, plus 5 root 2i, and then these two multiplied together is going to give you this times this. Now if you want to look at it, put it together. It's for sure a minus. Sorry, I ran out of room. It's, you have root 2i times 2 root 2i. So the two 2's come out along with this 2, and you have 4 and then I squared. So this is equal to negative 4. But you have a negative here, so it's a positive 4. Okay? So now these two are alike, and these two are alike, so your answer is 39. And then these two are alike is going to give you negative 9 root 2i. So this is the answer to 53. Last 4, you are going to divide. The object is to get rid of the radical in the bottom, which is actually square root of negative 1. So you can just multiply this by 3i. You could actually just do I if you wanted to. And that would actually, I would be work just fine. You want to just do I. So you end up with 2i over 3i squared. This is going to give you a negative 3. And you have no more radical in the bottom. You could do the same for this. You could multiply this by I and this by I. So 2i plus 3i squared over 2i squared. So this is 2i. This is going to give you negative 3. And this is going to give you a negative 2. And the last 2. These ones you have to multiply by the conjugate. The conjugate of 4 plus 2i is 4 minus 2i. So we're going to FOIL the numerator. 6 times 4 is 24. 6 times negative 2 is negative 12i minus 12i. And this is going to be a negative times a negative is a positive 6i squared. We'll simplify it in a minute. 4 times 4 is 16. The next 2 cancel out. And then you have minus 4i squared. So I know that this is actually equal to negative 6. And when I combine negative 6 with 24, I get 18. These two add up to be negative 24. This is actually going to be a 4. 16 and 4 is 20. So now what I want to do is I want to see if there is a number that goes into all 3 of these. Well, I know 2 goes into all 3 of them. So I can reduce this by 2, this by 2, and this by 2. So my final answer would be 9 minus 12i over 10. Two goes into all three of these. And the last problem, 67. You're going to want to first rewrite square root of negative 4 as 6 minus 2i. So your conjugate would be 6 plus 2i. 6 times 4 is 24, plus 8i. The bottom, 6 times 6 is 36. The next two cancel, and then minus 4i squared. Well, this goes to positive 4. And 36 and 4 is 40. And now you're going to want to see what number goes into all three of, is there a number that goes into all three? And yes, 8 goes into all three. 8 goes into 24 3 times, 8 goes into 8 once, and 8 goes into 45 times. So your best answer, reduced, would be 3 plus 1i over 5. And that concludes chapter 7 and complex numbers.